Hello everyone. Let's do some more example of hospital rule. The next example, I name it numerical method is inferior in honor of one of my favorite transformer, Soundwave. Again, those are references from the past. You have no clue what I'm talking about. I don't care. It's still cool. Okay. Anyways, so let's compute the limit as x goes toward 0 of 3 to the power x minus 1 over 2 to the power x minus 1. Of course, the first thing you do is you replace x by 0, you get 3 to the 0, which is 1 minus 1, which gives you a 0, and over 2 to the 0, which is 1 minus 1, which gives you 0. And that's bad. But that's all right. That's a good bad in the sense that you can apply hospital rule. So you differentiate the numerator and the denominator respectively. The derivative of 3 to the power x is ln of 3 to the power x minus 0, and the denominator, the derivative of 2 to the x, is ln of 2 times 2 to the x. And now you try again by replacing x by 0. You get ln of 3 times 3 to the 0 over ln of 2 times 2 to the 0, 3 to the 0, 2 to the 0 is 1, so you just get ln of 3 over ln of 2. And that's your answer. If you're really a freak, you could write this as log base 2 of 3. The point, though, is the reason why this example is called numerical method is inferior is that your algebra will not allow you to simplify this 0 over 0 problem. And if you try to guess it using a table, log base 2 of 3 is a very, very ugly number. Okay, 2 to the power of 1 gives you 3, so that's an irrational number. So it's very close to impossible to guess this limit. Okay, so hospital rule here really does the trick very well. All right, for our next example, we have the limit as x goes to infinity of x times sine of 1 over x. So if you replace x by infinity, you get infinity times sine of 1 over x, which is sine of 0. Sine of 0 is 0 times infinity. That's a bad product. So you need to flip one of the two. So here between x and sine of 1 over x, the term that is easier to flip is the x that will turn into a 1 over x at the denominator. So here this limit can be rewritten as the limit as x goes to infinity. So I'm bringing my x downstairs here again. So you get sine of 1 over x over 1 over x. Now if you do replace x by infinity, what will happen here? You're going to get sine of 1 over infinity, which is sine of 0, which is 0. And downstairs you get 1 over infinity, which is 0 over 0. So yeah, it's still bad, but not as bad. So now we can apply hospital rule. So you're creating a brand new limit by using the rule. So remember, hospital rule is just the green light to differentiate the numerator and the denominator separately. So derivative of sine of 1 over x, by using a chain rule, you're going to get cosine of 1 over x times the inside derivative, which is minus 1 over x squared, over the derivative of 1 over x, which is minus 1 over x squared. Oh yeah! So now we can see that these two will cancel perfectly, these 1 over x squared, and you're just left with cos of 1 over x. So if you plug in infinity in this, you're going to get cos of 1 over infinity, which is cos of 0. Cos of 0 is a nice 1. All right, now let's do one more example. Next example, let's compute the limit as x approaches 0 plus of cosecant of x minus 1 over x. If you do plug a 0 in here, the 1 over x, for example, will be a division by 0. So I have no choice to plug 0 plus in this expression. And as soon as you see a trig function that is not sine or cosine, you rewrite it in terms of sine and cosine. So cosecant is 1 over sine. So I'm going to replace every single x by 0 plus. So you get 1 over sine of 0 plus minus 1 of 0, 1 over 0 plus, sorry. Sine of 0 plus is 0 plus. 1 over 0 plus for now, I just left it as 1 over 0 plus, and these 1 over 0 pluses will become infinities. So you get infinity minus infinity. The sad, bad robot is back in. Now, this means we need to rearrange this expression, but here two fractions, hello, okay, let's combine them using a common denominator. So this limit can be rewritten as the limit as x approaches 0 plus. The common denominator will be the product of sine and x. So it will be x times sine of x. So the common denominator is x sine of x. So you need to multiply the first one by x and the second one by sine. Is that better for us? Well, if we try it, so if you replace x by 0, not 0 plus, you get 0 minus sine of 0, which is 0 minus 0, which is 0, over 0 times sine of 0, which is 0 times 0, which is really bad. Now, that's bad, but not too bad. Okay, so we can now apply Hospital rule. So if we apply Hospital rule to this expression, you get the limit as x approaches 0 plus. The derivative of x is 1. Derivative of sine is cos of x. And down there we have a product rule. X is multiplying sine of x, so you get the derivative of x, which is 1 times sine of x plus the first function times the derivative of the second one. The derivative of sine is cosine. And now what happens if you replace x by 0? You're going to get 1 minus cos of 0. Cos of 0 is 1. 1 minus 1 is 0. And then what about downstairs? You get 1 times sine of 0, which is 0 minus 0 times cos of 0. Mais voyons là, sorry, la misère. Cos of 0 is 1 times 0. You're going to get 0 over 0. So here, it's still bad quotient, okay? But it's not too bad. Bad quotient just means you need to keep the faith. You need to keep the faith, okay, and try it again. So let's apply Hospital rule again. Okay, so here we go again. So Hospital rule. So you're creating this brand new limit as x approaches 0 plus. The derivative of 1 is 0. The derivative of minus cos is just sine. And then you have over the derivative of sine, which is cosine, plus, I have to use the product rule now, the derivative of x is 1 times cos of x, plus the first function times the derivative of the second one. The derivative of cos is minus sine. And now if you try it again by replacing x by 0, not 0 plus, just 0, so you get sine of 0, all that over cos of 0 plus cos of 0. These cosine of zeros are 1s, plus 0 times minus sine of 0. So you get 0 over 2, which is a nice 0. So here I had a bad difference, infinity minus infinity. I was kind of lucky enough to be dealing with two fractions. By using a common denominator, I combined the two fractions, creating a 0 over 0 where I could apply the Hospital rule. I did apply Hospital rule. I got again a bad 0 over 0, and I applied again Hospital rule, and I finally got my answer. Anyways, for those 3 examples for that video, that's it. That's all. Bye-bye.